Okay, so in our last video, we have discussed about the specific heat capacity of fluids such as liquids, and we have also discussed about latent heat, and we have drawn a graph. We have understood the graph of the latent heat of the specific substances such as water, and now we will discuss about the specific heat of gases. So before this, we have just understood the video of calorimetry. What does and how does it works, and on what factors does it depend? That is depending on the heat lost and heat gained. That's the basic principle of calorimetry. But as a fluid, the gases are also considered to be a fluid. So we will now discuss the specific heat and terms related to the gases also. So what is the specific heat of gases? This would be nearly the same concept, but this is applicable for the substances like gases. So same thing, the specific heat of gases is nothing but the heat or the energy required to raise the temperature of a gas of 1 gram by a unit degree. So this is the specific heat energy of gases. That is nothing but the mass is considered to be 1 gram and the temperature change. So mass is 1 gram and delta T is 1 degree Celsius, or delta T would be considered as 1 Kelvin. Why we are considering delta T could be written as 1 degree Celsius or 1 Kelvin? Because delta T in degree Celsius will be equal to delta T in Kelvin. Why is this? Because the number of divisions between freezing and boiling point is same. So whatever be the changes in the Celsius scale will be equal to the Kelvin scale. So both are having 100 divisions, therefore there is whatever changes will be observed in case of degree Celsius scale, the same changes, the same number of divisions will be changed as per in the Kelvin scale also. So specific heat is nothing but the energy required to raise the temperature of a gas of 1 gram by unit degree. That is what we are discussing here. Now there is some limitations. All these concepts does not purely work on the gases. So what are the limitations? So we will discuss about the limitations now. So limitations of on specific heat of a gas. So for this we have to consider the Q, the change, because as we are heating up, there is a small amount of heat, means just for the sake to understand the concept, just we are taking the small amount of heat change, that is delta Q, as we are giving some amount of heat, so the overall thermal energy will be changed. So change in heat energy and by this the change in temperature would be let m be the mass of the gas and C, here C will be considered as specific heat capacity, or known as specific heat. Simple. So by this we come to the condition that delta Q is equals to MC delta T. By this we come C is equals to delta Q by M delta T. Now these factors has to be considered. So in order to consider first case 1, when the gas is compressed suddenly, then C mass is not changing. ठीक है, C is equals to delta Q by M delta T. So this will be, since delta Q is not changing, therefore C is equals to 0. And under what condition? When gas is compressed suddenly. Now second, one thing more, when the gas is compressed suddenly, the gas gains some random kinetic energy. Sudden increase in temperature takes place. So delta T is not equal to 0 here. But since the overall change in the heat energy will be remaining same, since it is an isolated process and under isolated conditions, so there is no change in the heat energy. Now second case is when the gas is heated and allowed to expand. When gas is heated and allowed to expand. So in this case, overall value. So gas does not have any fixed volume. It can raise up to high extent. There is no fixed volume. So what could be considered as? And if gas is heated, see the condition is, let me tell you just, when the gas is heated, the overall expansion takes place, and due to this expansion, the temperature again becomes same, since during expansion the loss of heat energy takes place. So therefore in this case delta T becomes 0, means there is no such increase. If the volume to be kept constant, then in such case the temperature could be considered as to be increasing. But since the expansion is also taking place, so overall temperature change is considered to be 0. So putting this value here, we get C to be infinity. So in this case, the specific heat of gases is infinite. Now third case. The third case is if the same thing, but if rate of expansion, if the rate of expansion is slow, means it is allowed to expand but slowly, not as per the temperature. So in this case delta T will not be equal to 0, means delta T will be positive, will have some finite value, and due to this the overall equation becomes positive. Now what? The third condition, if rate of expansion is very fast, you can say all of a sudden. So when the gases is allowed to expand, it's been expanded, all of a sudden it becomes cold, so it comes to be negative, since the expansion will reduce the thermal energy and hence the temperature will go decrease. Therefore the delta T, means change in temperature, is coming to be negative. So if the delta T value is coming to be negative, therefore the overall equation will also become negative. So these are the limitations of specific heat gases. Now we will move on to principles of specific heat of a gas. So basically there are two principles. Specific heat. So as I have just told you about the temperature, but there is some specific cases that are considered to be at constant volume and constant pressure. So the specific heat of a gas at constant volume is considered to be at Cv, and this is to be considered at Cp. So what are these? Let us discuss in brief. So it is nothing, since the constant volume is considered, means heat required to raise the temperature of gas of mass 1 gram by unit temperature by keeping volume to be constant. Now see, the volume to be kept constant. The volume needed to be kept constant, such as in pressure cooker. The heat is given continuously, but in pressure cooker the volume is kept constant, therefore gas expands. Pressure can be allowed to vary, means in pressure cooker what is happening? Temperature is being given continuously and the volume is kept constant. So if volume is kept constant, the pressure will increase on increasing the temperature. So in this case it is considered to be Cv. Now what we will talk about constant pressure. So in order to keep the pressure constant, we are not keeping the volume to be at specific value here. So in order to keep the pressure same, we can change the volume. So heat required to raise the temperature of gas of mass 1 gram by unit degree when pressure is kept constant. Okay, so these are the two cases. Now there is a relation between basic things, which is the overall Cp will be equal to Cp, that is capital Cp is nothing but the molar specific heat and is considered to be m Cp, where m is nothing but the molecular mass. It is molecular mass. And similarly Cv is equals to m Cv. So the ratio of two specific heat, that is, if we talk about atomicity of gas, is nothing but the ratio of Cp by Cv, that is mCp by mCv. So Cp by Cv. So the value of gamma depends on atomicity of gas. Now in our next video we will talk about what is the value and how does this gases behave if the Cp and Cv volume are being related to each other or compared to each other.